All right, this problem says a 5,000 kilogram truck is parked on a 7-degree slope. How big is the friction force on the truck? And it's a randomized case, so I'm going to just do generic problem. So we've got, I guess it doesn't matter which way the truck points. And I'm going to call the mass of the truck M, and I call the angle of the incline theta. The problem as I have it says that M equals 5,000 kilograms and theta equals 7 degrees. And then the question is, how big is the friction force on the truck? Express the answer to two significant figures and include the appropriate units. So what we want to do, of course, is do a free body diagram. And we would have FG. And then if this is the incline, we have the normal force perpendicular to the incline. And of course we have the frictional force along the incline. And if the truck is parked, then it's at rest and it's staying at rest, which means the acceleration is 0. That means that the net force is 0. So all we have to do now, well not all, but what we can do now is draw our triangles, because F net is also FG plus Fn plus FF. So if I take FG and I point Fn, that they will add up to F sub F. We'll know that this is a right angle because the normal force is perpendicular to the surface and the friction is always parallel to the surface, so they're always at right angles. And the real question then is, how do we get our angle theta into this particular triangle? So I'm going to go back up to the picture here, and I'm going to sort of cheat and say, well, if I had, this was my FG, and this is my Fn, and this is my FF, we can see that this angle is complementary to both that angle and this angle, which I might put like that. And two angles that are complementary to the same angle, so this one is complementary to the yellow angle, and this one is complementary to the yellow angle. Two angles complementary to the same angle are themselves equal, and so this angle here is theta. So we can see that if we do some trig stuff, and I'm going to start with, I guess, the sine. Let's call that theta. We'd have that the sine of theta is always the opposite side over the hypotenuse. And in this triangle, the hypotenuse is clearly FG. And the opposite side here is FF, which is good because FF is what I'm looking for. I can take this entire thing and solve it over and say that FF is FG times the sine of the angle. And of course, FG, remember out here, we know that we can always do that FG, F sub G is M times G. So down here I can write FG sine theta equals MG sine theta. So FF is, for my truck, 5,000 kilograms. Times 9.8 meters per second squared. That's F sub G. Times the sine of the angle, which was 7 degrees. Throwing in those numbers, we get 5971.2 6.597 newtons, way too many sig figs. They say to go to only 2 of them, and that would be 6,000 newtons, or 6.0 times 10 to the 3 newtons, although I think they take 6,000.